2012. It's indeed my pleasure and privilege to have a distinguished gathering of top IT professionals from the country. To start the proceedings today, we have with us Mr. Chidambaran Kollengode, Director Cloud Computing Nokia. Welcome, sir. Today he's going to talk about architecting cloud infrastructures for big data challenges. As a Director Cloud Computing in Nokia, Mr. Kollengode is responsible for building the analytics platform using Hadoop and plays a key role in the architecture and leadership in the big data space. The session will address cloud fundamentals, talk about Hadoop as an open source paradigm, talk about real world examples of how Hadoop is used in organizations he has been engaged with. Please come in, sir.
There we go. Yeah. So morning coffee time. Thank you. Thank you for the opportunity to come here, be with all of you and share some thoughts in this space. Right? Let me begin by saying that I am also in a learning mode. I am by no means an expert in this space, just that I've done a little more work and a few hairs have turned gray. So that's the only qualification, right? So we might not have a lot of chance to ask questions because of the time duration, but I will leave my email behind. So send me questions, send me your thoughts. All of us learn in the process. Now, how do I get to my presentation? So where is it saved? Doing cloud is easy, managing Windows is hard. Okay, so let's get started. A couple of quickies, right? Costs keep going up every day. We worry about things we have to buy, we have to do, we have to, and stay in the middle of all of this. So I was talking to a friend and he said, hey, look, I have a new insurance plan, new dental plan. So I was very curious, right? Yes, money saving, fantastic opportunity to figure out what it is. And he said, look, chew everything with my left side, right? Damage on the right, chew everything with the left. Good dental plan. How many of us can do that in organizations? How many of us can really have the luxury of not performing at a level we committed when we said we would do X, Y, or Z for our users, right? So it's in that space that we are in today. We are ever increasing need for managing huge volume processing and ever increasing cost of these infrastructures and very different paradigms. In the old IT world, we worried about things being very stable, putting up a requisition, buying machines, and by the time all that is done, a century is gone. Today it's very different. We want to be able to think of something and experiment very quickly. So that's where cloud comes in, right? And so I'll share some of my thoughts about what we have done. Before joining Nokia, I was with Yahoo, and before that with Amazon. So this interest for distributed computing started when I was in Amazon. We had a lot of data, clickstream data that we wanted to process, and the traditional database systems just started to get to a point where it became too heavy. And I actually went in and made a request for machines which came to close to $1 million plus. You can't get that kind of money. So we started thinking about what to do in order to do this processing. And very interestingly, what we did there motivated me to actually become part of the solution rather than worry about the problem. I've been in the analytics space for a while. But the big data analysis is a new paradigm because you not just work with data that is not structured, as people like to call it, but also with data that's got a high velocity, very high volume, very high complexity, different kinds of data. So that's the framework, right? So my talk will concentrate mostly on the work I have done and what I believe there is to do, and there's plenty to do, right? So as I say, this is a learning opportunity. Keep it interactive as much as we can, but send me notes. I have a lot to learn. This is a quick agenda. We'll go through what we think the cloud is. We'll go through the quick slides, the early slides a little quickly for want of time, but spend significant amount of time on the challenges and what our value proposition is. Okay, so quick note, cloud is nothing new. When we started using internet several years ago, we started using cloud in a way, right? www.yahoo.com. For those of us whose hair has started to become gray, when you were using the, okay, I have to figure out a way to do this. Sorry for walking across, but I'll try to stay this side. When you did that, when the news came up on Yahoo page, when the machines were old, you first got the leg, and then you got this little finger, and then the whole picture came. That's cloud actually. Because you just send the URL, and then the system figured out where to pick the components from, put them all into packets, and assembled it at the receiving end. Right? So cloud is nothing new. It is just that with the advent of the communications across continents, the ability for us to use cloud for computing has become much more real. Okay, so that's This is really what it is. We were doing this in the 90s, nothing new. Then we started putting processing, but still believed that data is not safe. Somebody can steal my data. And then we moved on and started using storage. Right? This is like the classic story. We need to believe in something before it can happen. A little young child was drawing, a little 6-year-old girl was drawing the painting, and then the teacher comes to her and asks her, "What are you drawing?" "Teacher, I'm drawing the picture of God." Nobody has seen God. Give me 5 minutes, you will see it. Right? So that's the enthusiasm we all need to have as we embrace these new technologies, because we don't know where we are going sometimes. And that's a good thing, right? Because a lot of these discoveries happen when you don't know where you're going, but you have a vision. You don't know where you're going, but you have a vision. Hey, I want to get there. I want to make computing cheap for my company. Instead of spending millions of dollars to do something that should be done very easily, can I do something which can make it easy to do at a much lower cost? Right? So that's the vision. The vision is there. If you don't have a vision, you don't know where you're going. You have a vision, but the path for it may not necessarily be everything available at the time we start. So good paradigm to have. And cloud is in that area now. We have moved from that hump of, hey, I don't know what this cloud is. Is it usable? Is it a myth? We have moved to, hey, it's usable. And some of us are actually using it in production, and I'll share some of those with you. And it is no longer a luxury. Even mid-sized companies are moving into cloud purely for cost. Cloud began as an innovation, and we'll talk about that. But now it's moving away from the paradigm of just being innovation to something I must use in order to be competitive and to survive. Okay? So, traditional systems, we'll quickly walk through this. All complexities. Yeah. Remember those days? I remember. I don't know how many of you are. I see a lot of young faces here. So, one good thing about talking in conferences is you feel young after you go back, which is good. So, which is good, I think. When we were working in systems that were mainframes, by the time you had something done, you could actually have a generation pass under your feet. Right? Put an order for a machine, the machine comes and somebody installs it, and then you see if it works. If it doesn't, you go back the entire cycle. Who wants to do that these days, right? I mean, impulse buying. How many of us do that? I don't. How many of you do impulse buying? We need things quickly, right away. Yeah, I do too. That's why I kept it like this, right? I mean, I want to do this. I actually want to put both hands up. But that's life. We need answers quickly because the competition is doing it. It is not that I have a luxury. I don't have a choice. Right? My competitors, the mobile phone people, are doing things at a very fast pace. And I don't have a choice. It's not that it's a luxury anymore. There's no choice. I have to do everything that my competitor is doing just to survive. Not to overtake, just to survive. Right? So, operations toggles. Oh, my machine broke. 24-hour SLA. So what do I do for 24 hours? Go home and sleep. Can't do that these days, right? Internet. Can anybody think of having some of our popular internet sites down? Imagine ICICI Bank being down for 2 hours. How many of us scream? Right? So the world has moved away. So it is no longer something we just have to do. It is something we have to do to survive, not even move forward. Right? So a couple of two people were digging a road. One person was digging and another person was filling mud. So there was a passerby who looked at it and said, this is nice, very interesting. So he waited till that one road was done. I live in Girinagar, by the way, that's happening now. They're laying new sewage pipes. And then they went to the next road, did the exact same thing. Dig, fill. So this gentleman had to go and ask them, look guys, what are you doing? It just doesn't make sense. Why are you doing this? Oh sir, we are actually 3 people. One of us have to dig, the other has to plant a sapling, and the third person has to put mud. The person who is planting the sapling called in sick. So we continue to do what we are asked to do, right? A lot of work, no progress. So today we are in that space. There's really a lot of work we all need to do just to keep up, just to be those 2 diggers, just to survive. I have to do my work to get my day's pay, right? So developer trussles, obviously we all know this, right? We all really know this. And this is an interesting study. As I was looking through some of the interesting articles about what makes sense for cloud, this just popped up, right? Interesting study. 60 to 70% of the time that we use in our day-to-day job as IT people goes for absolutely unproductive work, right? So it's a very simple question to ask. What do I do to get that unproductive time back so that I can do something much more productive? Yeah? For every PL SQL program that you write, if you have to write an exception statement, why can't I take all of those PL SQL exceptions and make it a library that somebody can call? Fair? People agree with me? That's cloud. So a lot of what you have to do in terms of getting the machines, buying them, getting the compute power, having the ability to scale at peak, is all done by a platform. So you go and build what you need to build quickly so that you can now not just keep up with the business but actually do something better than the competition. Right? So that's the paradigm for cloud. So very interesting study, extremely interesting study. So this is probably something that should motivate all of us to looking at what are these new ways by which I can just now not survive but stay ahead and leapfrog up. So to me this is cloud, right? And the key value that we get, so we have not solved all of these, right? We have not solved all of this, obviously. But this is what eventually cloud will turn out to be. So it's in the early stages, but this is where I think it'll eventually head into. So what's our story so far in Nokia, right? Yeah, this is all great. Cloud is all fantastic. Everybody talks about it. But can you tell me something that you have actually done? So let me walk you through a couple of slides to tell you the things that we use in Nokia. So our premise is we began with the need for innovation, right? In other words, in the old IT world, stability is very important. You have to run a job, you have to submit. How many of you have used, I shouldn't even ask that question, but I'll still ask, right? I want to feel young. How many of you have used punch cards? Makes me feel good, right? So, sorry, just have to have some fun. Apologies. Those days, by the time you have to run something, you have to punch these cards, take them to somebody who will load it for you, and remember, by the time you punch and take it, don't drop it. You're screwed if you drop it. Right? Some of us can relate to that. Right? So those were the days when we were actually worried about how to get something done. But remember, you had a lot of time because nobody else was doing it. Right? Today, that's not the paradigm. If you sleep, somebody else is actually trying to overtake you. So there's no question of not only punching the cards, but making sure that you do something much faster than punching, which is have the resources available so that, hey, I got an idea, I want to go experiment. Moving away from the old paradigm of put a request, somebody from IT will get back to you. Whenever. SLA, no SLA, we will get back. We have a lot of other jobs to do. You're not the only guy or the girl, right? Too many things to do. Those days are gone. We should be able to go experiment and have a machine available for us to do that experiment, because ideas, all of us are fantastic human beings. We get ideas and then it evaporates if we don't use it, right? So we use that excuse when we want to use cloud. I get an idea, if you don't allow me to work, that idea will go away. So what do the people do? Oh yeah, give you enough machines, right? Provided you can generate those ideas. So we began in Nokia by using cloud for innovation. Right? So our paradigm was not, hey, we have to save a lot of cost, therefore go buy these machines. Our paradigm was, look, we need to do things quickly, therefore we'll invest and then provide our analysts, our scientists, our data users the ability to do things very quickly. That's all. That's where we began. And our story so far, right? We started in 2002H is second half of 2010. We have come a long way, right? And it's very interesting that within a really somewhere it comes. So within a really short time, we have already gone up to the petabyte stage. Right? To me, big data is at the petabyte stage. And today's big data can become tomorrow's medium data. It's a very time-relative thing, time-sensitive thing. As the storage and the computation grows, right? So how many of us use the 8.5-inch floppy drive, 8.25, whatever, floppy drive? I have, right? For 300 gig, it used to be a prized possession. You can store 350 MB of data. Wow, right? Big data those days, because you couldn't process it. A textbook fitted into 16 floppies. I remember carrying them, right? But very precious, big data, really big data. Right? So this is a very relative thing. As the time capsule changes, our ability to call what is big changes. What's the stack we use? This is the one we use, right? Again, this I think for those of you who are thinking of going to cloud, it's very important to get this down first. Right? What is the stack that I will use? There are choices available, and you have to decide what is the stack that you have to use. So I just want to put up this slide to give folks here an ability to go and think through all of these. I mean, these are the stack pieces that you will need, and if you decide to experiment with cloud, right? So this is what we do now. Big picture, but don't worry too much about it. There is a option for us to get data in. We use completely distributed computing to store all of our big data, right? And the users. So yeah, big data is all great. It's fantastic. I have a lot of information that I have stored, right? I mean, if you look at this little mobile device, wherever it is, it's got a ton of information, right? But how do I make it usable? How do I make it actionable? That's the key thing. It's one thing to have a lot of data, but it's a completely different thing to be able to take that data and make it useful for something that you might really draw some insight on. That's the challenge, right? And that is the reason why we are using Nokia, and why we are using cloud in Nokia. Technology problem. I do remember silencing it, but okay, right. So this is what we do. I mean, a lot of this data exists. A lot of this data comes to us from people using these mobile devices, right? And then we combine and provide. Okay, there's a little bit of some pieces are not showing up here for whatever the reason is, but we believe that we want to use cloud for mining huge amounts of big data and drawing that little ounce of information that we think will be smart data, right? Simple things like, there are things you do with this phone, and if there's a way for me to tell you what you will do at 4 o'clock based on what you have been doing at 4 o'clock for the past 5 days, for example, calling your mom, calling your friend, great, right? I don't have to punch 5 buttons. At 4 o'clock, if I can pop that number up on the front, valuable, useful in this busy lives for us. When we get an idea, we want it right away. When we get to do something, we want to do it right away. Right? That's the world we're all in. So that is actionable data, right? Data is big, yeah, but how do I get something out of it and use it for what I need to use? That's where these technologies come in. So remember the stack that we talked about. It's important for you to think about that stack if you're thinking of getting into the cloud, right? Just have in your mind, what is it that I'm going to use in order for me to be successful. You will need all those elements in the stack in order for you to be successful. And how do we use smart data? Pretty significantly, right? A lot of contextual searching, targeted recommendations. As you're driving, if we know you drink coffee, it'll be great for us to tell you, hey, coffee day is coming another 1 mile to the right. Right? Good information. If we know you drink coffee. How do we know you drink coffee? Maybe looking at a lot of data, maybe looking at your location data. By the way, there is no compromise on privacy in all this, right? I mean, we are very careful about people's identity. But from a pattern matching perspective, hey, we know these are the kind of things you do. And then if you're driving, wouldn't it be great to show that? Right? So those are the kind of information that companies want to do to personalize. Right? It's no longer crowd. It's no longer marketing, putting an ad on the TV so that everybody will consume. It's very targeted these days. Right? How many of us watch TV? How many of us watch TV substantially less than what we were watching 5 years ago? Right? This device has become so ubiquitous. So you forget it for a few minutes, you have a problem. Right? It's almost like a symptomatic problem. Right? So that's how we are. So everything is centering around this little screen. And how do we make it personal? Because obviously you don't want to show huge advertisements in this that nobody will watch. So you got to make it very personal. That is the challenge. Right? And it's only going to become worse as we move away from the... I read an interesting article yesterday I think in the Hindu or the Times of India about, do we really need the desktops anymore? Brilliant question, right? Answer is an obvious no. There are so many people who are very happy without a desktop. It's an irrelevant time to ask a question, but nevertheless a pointed question. And I think a few years from now, maybe days from months, I don't know, you'll ask, do you really need a laptop? Maybe this and then those little screens that they sell now. I don't know if you've noticed, electronic screens, thin light ones. You can just put it in your pocket and walk. So you can sit there, put this mobile phone and put that keyboard and start working. Right? That's where the industry or the world is moving. So you got to, how do we get all this data, which is big, get that ounce of information and put it into this little piece? Very little, right? You can't put a lot into this. Right? So that's where the challenges of big data computing and cloud computing comes in. So what are some of the challenges that we, who is monitoring the time? Maybe I am. Okay, I have 15 minutes, that's fine. So here are some of the complexities. Here are the kinds of data that we handle, right? People like to call unstructured data. There's really nothing called an unstructured data in my mind. Right? Data has always been unstructured. Database provided you a structure. Right? Data has always been unstructured. So the paradigm for data comes from the way you handle the data. So if you look at a text document and say I can draw some content out of it, it becomes structured. Right? So it's probably non-traditional data that's a better usage. There's nothing called unstructured. If you can give structure, so before the database came, how many of us talked about structured data? Right? So if you put the right processes and right frameworks in place, any data that you have becomes structured because you can make sense out of it. Right? So, but nevertheless, very interesting to look at what the big data space encompasses. Right? Streams. How about this? You're watching an ad on the TV, you like a little clip, take a picture of that clip on the phone, But remember, you always have this. Not having this is a crime these days. Got to have it with you, always. Even while taking bath, watch it, right? So very easily you can take a picture. Agreed? Now imagine if you take a picture, I can do all these fantastic things in the back end and say, he took this picture, but by now, somebody else is also taking this picture. Now let me tell him where I can find this. Completely new paradigm. What we used to do earlier, watch an ad on the TV and then say, remember it, store it here, and go looking for where I can find it. This little device can change all of that, right? Streams. Ability for us to be able to take pieces of data, combine it with a much bigger space, and give you very insightful, meaningful, relevant information. That's why you need big data. That's why you need this huge processing. So that I can kind of do what others have done and more or less accurately give what I think you will need. Okay? Data diversity challenges, how to analyze this. Challenge, huge challenge. Right? Scientists. You're a scientist looking at the data. You don't care a damn about how to store it so that I can get fast results. You don't care. You want to type something, you want to get a result. These days we worry about, if I have to get data very quickly, I have to create an aggregate, and I have to create that aggregate in such a way and partition it in such a way that he can get his answer very quickly. We think a lot about how to store data in order to get value from the data. Wouldn't it be great if the system can automatically tune so that we don't worry about how to aggregate this data and put it in a way that as a scientist you can get an answer quickly. Right? Very interesting challenges. We can all spend a lifetime doing PhDs on some of these, right? Which is good, job security. Platform challenges, as we build the platform, phenomenal amount of challenges in terms of how to keep it stable, how do we handle failures. And one of the key things when we do cloud, at least in my paradigm, is that we don't have all the answers. I began this conversation with all of you by saying that I don't have all the answers. So one of the things we do is encourage failure. And the second thing we also do is we actually reward failure. So if somebody comes and says, I've tried something and it doesn't work, it's a great thing, right? Edison's principle of how he invented the electric bulb. You almost always learn through mistakes and through your peers. There's no textbook guide about how to do this, right? So which is also good because you can make a mistake and your boss can't fire you really because he doesn't know the answer, he or she doesn't know the answer, which is good. Performance challenges, right? Lots of performance challenges when you build this, right? Key thing, how do I know how well my cluster is being used? There's no good way to find it out because there is so much competence across jobs, across how you run parallel application. So the reason I'm putting all of this up is we are at the very early stages. Very, very early stages. Right? So a lot of interesting work to do, and I'll share with you some of how we are solving some of these problems. Challenge, opportunity. Obviously, very big challenge in terms of how to adapt. As a user, if you don't have a cloud in your own premise, you have to wonder about, if I go to Amazon, will I get locked in? Can I move to somebody else if Amazon starts to charge me more? Growth, right? Very big problem being how do I scale quickly? That's the problem. Remember, we began this conversation by saying, I want to scale, I want results quickly. How do you do 4,000 node clusters? That was the cluster size I was working with when I was in Yahoo. How do you build a test environment to test something on 4,000 nodes? Impossible. So you have to write interesting simulation software to simulate as if you have 4,000 nodes, right? Another challenge. Another job security. So lots of opportunities. And what have we seen, the benefits that we have seen in Nokia, right? Very interestingly, we went through an interesting phase of building the platform, advertising what the platform can do, and then having this very skeptic, can it do? Is cloud real? These guys don't look like they have two tentacles on their heads, and can we rely on them? They seem to say cloud works, but right? So we went from that phase to, this actually works. And so now we have a very interesting problem where we are not able to manage growth. We are going at faster space than we can add machines. But luckily Hadoop scales very well, right? So that's not that big a deal, but right, we have had the ability to reduce developer time to do things that they would normally do just to keep going. We pushed a lot of them down the stack, right? And this is the key benefit. Ability for us to be able to do things in very agile fashion with stability, right? You can be agile, stable. Combination of that is fantastic. Either one by itself is useless. Very stable, takes a long time. Old days. Can't do that anymore. Remember the speed? I need answers now. I need answers. Actually, if I think something today, I need an answer yesterday. That's how fast the world is progressing, right? So, agile, is a given. But in order to do agile, you need to have a stable base, and that's what we build. We build the platform. The platform called cloud computing for our users to come and do things that they believe are important for them to do in a fairly reasonable amount of time. For us, again, a lot of areas that we use, right? A very, very key area for us, spikes. Right? Very, very, very critical. From a cloud perspective, one of the key things that you can do to manage spikes is to design your system in such a way that you don't have to buy n number of machines and keep them for something that might happen only in a couple of months a year. Right? Huge benefit. And this is also an excellent, earlier what used to happen to us was that we were obviously keeping the data in some other bigger database systems. Expensive. Very expensive. So we used to throw data. Now what we do, we keep everything so that somebody can come and first warning for time, I still have 5 minutes, I think. Right. So again, as we continue to do this, our ability to demand space in a dynamic fashion is very huge in this environment. You don't go through those whole 9 yards of getting some codes. Those days are gone. You just can't do. Okay, so how did we do all this? Yeah, one way to do this is to go buy everything, and another way is to go use a open source system. When I was working in Yahoo, we developed, I was in the team that led the MapReduce development, and MapReduce was open source. And one of the key paradigms for us to use open source was, like, I really like this, right? Together we win, right? Every one of you have intelligent ideas. And open source extracts those ideas and puts them all into a place that people can use. And I'm a very big believer in open source. And all of Hadoop in Yahoo was done in open source. And we spent a significant amount of time trying to encourage the open source culture in India. So all of you software developers who are all here as software developers, please embrace that paradigm. It's good. It's good to give and get back. Right? We engage with the universities. Remember some of the research problems I was talking about earlier? We engage with the universities very actively and work on wanting to. All right. We are very, very actively engaged in doing some cutting edge research. Why does open source work? Right? Collective intelligence. It harnesses the collective intelligence. Right? I mean, there is a very, very interesting shift about how do we accelerate development. I can only hire so many people to do the task. But if I can collect and harness the intelligence of a lot of people whom I don't pay much, in the sense of employment, that's what I mean, not in terms of actual value. Right? It's a huge benefit for us to get good software that we can use. Right? I'll leave you with a closing statement. Fictitious discussion between Mahatma Gandhi and Vijay Mallya. Right? So Gandhiji says, alcohol is not the answer to all your problems. So Vijay Mallya thinks and retorts back, alcohol may not be the answer to all your problems, all your questions, but if you don't get the answer, alcohol helps you forget the question. Right? What we want to do in this space is not to have you forget the question, right? Not to drink so that you forget the question. Okay? So that's kind of what we are attempting to do. Right. Thank you for the opportunity to share some thoughts. Do you have time for questions or? Any questions? All right, thank you all. It's a binary state, either everything sunk in or nothing. Thank you.
Thank you very much.